Hello everyone, I'm Taro Handa from Japan Meteorological Agency. I've been in charge of RGB composite since last year. Please let me read my papers. Okay. Today I'll mainly talk about JMS user support activities for RGB composite. And in addition to that, we are now proceeding the operation for switchover from Himawari-8 to Himawari-9. So I'll also talk about the switchover plan and the comparison for RGB composite between Himawari-8 and 9. This is my first time to give a presentation at an international meeting. I'm nervous in a way. As I said in my introduction, actually I'm not good at English very much, so please listen to me gently. Today's contents are like this. First, I'll talk about the current status of Himawari. Firstly, I'd like to talk about the basic status of Himawari-8 and 9. As you may know, their stationary position are around 140.7 east. So it can be said they are covering with Asia and Oceania. Himawari-8 can get 16 different bands through the observing instrument named AHI, Advanced Himawari Imager. They observe 3 visible, 3 near-infrared, and 10 infrared bands. Light table shows how long wavelengths each band is observing and its physical properties. Based on this table, JMA makes and adjusts RGB recipes. Himawari-8 and 9 carry the same observation sensors. Recently, we are proceeding the plan to switch the main satellite from Himawari-8 to 9. I'll talk about the difference between both satellites in last part. Now, Himawari-8 and 9 have been running in parallel since 27th September. After checking, JMA is planning the switchover around December 2022. Next, I'd like to talk about the user of Himawari. As you can see, Himawari data are used in many areas, mainly in Asia and Oceania. Himawari cast receiving system is used by 33 National Meteorological and Hydrological Services, NMHS. They can receive the Himawari data directly from the satellite. This data sending method is mainly for places with weak ground infrastructures. For example, damaged sites due to a large-scale disaster, remote mountainous areas, island countries, and so on. 23 NMHS have a Himawari Cloud account. This transmitting method with landlines can send bigger data than former one. Especially, you can get all bands of AHI and the highest resolution observation data. If necessary, JMA uploads and issues an account and a password for each institution, and you can use these data. EUMETSAT also has this account. Finally, web service is used in 42 areas. Next, let me talk about Himawari Request. It is a service JMA began in 2018, which focuses on reducing local disasters. As you may know, AHI has 6 observing areas, including full disk observation. Among them, Region 3 called Target Area Observation can provide imageries flexibly. The Himawari request service allows National Meteorological and Hydrological Service to request particular target area observations in order to use this flexibility on an international scale when the observation slot is available. JMA has accepted 147 requests of 22 NMHs since this service started. These images are about a large wildfire at east coast of Australia, requested by Bond. Himawari request can offer observations in the particular area every 2.5 minutes. RGB composites also can be offered. JMA expects the Himawari request service to support disaster risk reduction activities in the region based on the monitoring of extreme events. So we look forward to your active use. Next, I'll explain RGB quick guides. MSC has been promoted the widespread use of RGB composites, particularly in field of the weather forecast and the volcanic eruption observation since they launched. Within JMA alone, we can feel more and more people are becoming interested in RGB composites. For further use, we created RGB quick guides of Himawari, which is based on the one created by other meteorological satellite training centers, such as Imagery and Support. These quick guides are designed in order to browse essential information easily for satellite data and imagery users, including forecasters in daily work. So we made them simpler, easier to understand, and more quickly usable. These quick guides are composed of a pair of front and back side. So, for example, like the upper image, you can use them conveniently by inserting printed RGB quick guides in plastic clear file folders. I'll show you the appearance of them in next slide. The appearance and structure of RGB quick guides are like these. On the front side, the benefit and limitations are written briefly. So we can see each RGB composite is suitable for and points to note for use at the top right part. And you can also see typical cases and its explanations with an image. The bottom table shows a recipe for each RGB composite and main phenomena for each R, G, and B. So we can get basic information from the front side. In addition to that, you can get further information on the back side. There are more typical cases of other colors not showed in front side, and there are more color interpretations easily to find suitable color. You can download these RGB quick guides from the JMA MSC website. Main page offers each RGB composite by the difference of origins, WMO recommended schemes, well-known RGBs, and polar orbiting satellite origin image RGBs, and JMA original RGBs. So if you want to know more about JMA original RGB composites, you should see this page and download them. Of course, we have prepared the page to find RGB quick guides by purpose. You can find suitable RGB composite briefly and After that, you can learn more about each RGB composite with each quick guide. We also create and upload a PDF list last year. In addition to create RGB quick guides, JMA published a technical note about RGB composites. This technical report has the explanation about basic mechanism of RGB composite and each RGB composite in more detail. So I recommend this article for first-time learners. This report is also available on the WMO-CGMS website. From now on, I'll talk about public relations of Himawari RGB. First of all, I'll talk about the training event in AOM-SUC 11, hosted by CMA from 28th October to 5th November 2021 virtually. AOM-SUC stands for Asia-Oceania Meteorological Satellite Users Conference. The purpose of this conference is to improve collaborations among NMHS space agencies and user communities of Asian region to enhance the use of satellites. So most participants of these meetings are Asian and Oceania people who often use Himawari data. So JMA had a training session to users of Himawari. We had a 30-minute lecture part and one hour practice part. In the lecture part, I gave a lecture about basic satellite information and what is RGB composite. In latter practice part, I lectured how to use satellite with a manual and a real instrument. This training event was almost well received, so I'm happy if the participants are used to satellite through this event. Okay. In previous slide, I said satellite. This is a sophisticated display software visualizing meteorological information in multiple dimensions. This tool comprises various functions to analyze satellite images. Using this function allows to conduct an analysis equivalent to the analysis being conducted in the MSC. For example, numerical forecasts, observations, satellite data can be drawn at the same time. Of course, you can make RGB composite easily with this tool. You can also change recipes of RGB composite. So you can create your original RGB composite and verify it effectively. So I showed how to use this tool for Himawari users in AOM-SUC 11. Next, okay, let me advertise AOM-SUC 12. Actually, it's JMA's turn to host AOM-SUC. AOM-SUC 12 will be held virtually from 11th to 18th November 2022. I'm sorry, the reservation of abstract has already finished. Thankfully, we have received a lot of abstract from many participants. Training sessions like the previous slides are going to be held in the first 2 days, and individual presentation sessions are being held in the next 3 days. If you are interested, please check the second announcement for non-presentators, which will be published soon. For holding this conference, we are greatly cooperated by today's participant, Mr. Bodo. Thank you in advance, Mr. Bodo. ありがとうございます。 And of course, all of other participants, thank you for your cooperation. So we are looking forward to your participation. Next, I'll show you our monthly activity. We post reports about the phenomenon that happened in each month. In these reports, we show RGB composite videos with an explanation of the phenomenon itself and color interpretations of each RGB composite. For example, this slide shows the thunderstorms by the passage of upper air low pressure in September last year. I think this phenomenon is a good example of air mass RGB composite images. As you can see, the orange area, which describes a trough of pressure is moving southward, and cumulonimbus clouds are forming along them at the same time. Like this, we choose phenomena which non-meteorological people can easily understand and come out RGB composites every month. Next, I'd like to talk about this phenomenon, an eruption of an undersea volcano at Fukutoku Okinawa. From 13th to 15th August 2021, a very large eruption of the undersea volcano Fukutoku Okinawa in Japan was observed. This eruption is the largest post-war eruption in Japan. The smoke was able to be seen clearly from Himawari. In the satellite video, we can see volcanic humus growing to west-southwest direction. On the morning of the 15th, you can also see the change of sea color by this eruption in the right image. As you can see in this map, Fukutoku Okinawa is far from Honshu, the main part of Japan, but this eruption affected a lot to some southern islands of Japan because of its pumice. I'll explain the details in the next slide. Okay. From now on, I'll explain the effect of drifting pumice and how we observe them with RGB composites. After drifting for 2 months, pumice got to Okinawa, which is located west to northwest from Fukutoku Okinawa and southern part of Japan. Okinawa is here. Pumice covered beaches around Okinawa, and it affected the industries a lot. A lot of fish were dead. Ships might be broken if they were used on pumice, so it affected the fishing industries the most. Of course, people in Okinawa had to remove pumice too. I heard that it costed a lot to solve these problems. The left-hand image shows a covered beach and sea. This picture. Okay. The gray areas are pumice. As you can see, very huge area were covered, and you can guess much effort was needed to remove them. We used RGB composite to observe pumice then. The right-hand image is basically made by natural color RGB, but we added a special method called pan sharpening to enhance the drafting of object. This method merges a high-resolution panchromatic and low-resolution multispectral imagery to create a single high-resolution multispectral imagery. Band 3 is assigned as a high-resolution imagery, and natural color RGB is assigned as a multispectral imagery. Following is a way to adapt this method. At first, the RGB format of both imageries were converted to HSI formats. Each of HSI means hue, saturation, intensity. Secondly, we replace intensity of natural color RGB to the one of band 3. Finally, return back to RGB form. Using this process, drifting object was enhanced and we were easily able to recognize the object we appears to be PMized. This part, okay. Finally, I'll talk about the comparison of Himawari-8 and the next generation Himawari-9. Let me talk about primary data of Himawaris. In the Himawari status part, I said both of Himawaris have the same observation sensors, so there is not large differences between Himawari-8 and 9 for each band. However, each band of Himawari-8 and 9 may have slight differences because of the difference of each individual instrument. These images show the differences between Himawari-8 and 9. Because of wavelengths, visible band and near-infrared bands are calculated by reflectivity, and infrared bands were calculated by brightness temperature. The results were calculated by directly subtracting the Himawari-8 values from the Himawari-9 values for each grid. As you can see, among visible band and near-infrared bands, band 1 and band 5 relatively have large differences, just as band 7 and band 16 have relatively large differences among IR bands. This may be caused by the difference in sensor characteristics. Talking about RGB composites, perhaps these bands affect the degree of color differences. Please pay attention to these differences when you use Himawari-9 data. In previous slide, I said band 1, 5, 7, and 16 have relatively larger differences than other bands. I have prepared two RGB composites, True Color RGB assigned band 1 in blue and Day Convective Storm RGB assigned band 7 in green. Please look at these GIF images carefully. Himawari-8 and 9 images are being displayed alternates every second in these images. Looking at clouds in image of True Color RGB, you can see the image of Himawari-9 is little bluer than Himawari-8. Look at this part. Himawari-9 is a little bluer than Himawari-8. I think it's affected by band 1. When you look at the convective storm RGB, yellow is more enhanced in Himawari-9. For example, look at this part. This is thought to be the result of the strong green color. After gathering more data and opinions from users, we will consider whether it will be able to use properly and if we need to make adjust color balances. Finally, I'll summarize my presentation. Okay. JMA is switching over from Himawari-8 to Himawari-9. Himawari requests from NMA.js is always welcome. RGB quick guides were published and can be seen on JMA MSc website. Some supportive activities have been given, such as training event and monthly reports. AOM-SUC 12 hosted by JMA will be held next month. Drafting objects like pumice around Okinawa was able to be seen in RGB composite and observed for some months. Between Himawari 8 and 9, they have a little differences in some bands. After many data gathered, we are going to consider whether color adjustment are required or not. Okay. Thank you for your attention. My personal data is bottom. Okay. If you have some questions, feel free to send an email to me. Thank you very much.
Yes, we have a few questions. Javier.
Sorry. Please speak slowly, please.
Sure. If the RGBs will be slightly different with Himawari-9, will the quick guides be updated for the new colors?
Yeah, I think so. Okay.
So from a science side, how will you determine whether or not the adjustment is worth going forward with? I think that's something, because I have some work on that later too, that's maybe something that I struggle with is constantly tweaking, and at what point do we need to tweak and adjust or just accept and change the training?
I'm sorry, I didn't catch.
Yeah. Okay. Yeah. So the question, correct me if I'm wrong. The question is, how do you decide which RGBs to make changes to due to the differences between 8 and 9?
Okay. Okay. I discussed about it, including about it. Okay. I discussed about them, include them. Okay.
Yeah, in your presentation, you said you would discuss with the users after, I guess, about change. And so is that part of the decision process on making, on deciding which ones to change? So you speak with your users?
Okay. I think we'll talk about the difference of them in, for example, AOM-SUC 12, and users will okay. Okay. Can we talk later? Okay.
Yes, that's absolutely. Thank you.
I'm sorry.
Any follow-ups you could?
No. I mean, you're doing great with your English, so don't feel bad. We'll talk later. Yeah.
Thank you very much.
Only to an encouragement to talk because I think the whole issue of when we have much, much more sensitive instruments and these changes happen, particularly in the visible, we're all going to experience this. And I really appreciate your challenge, because if we change everything all the time for the operations, it's too hard. But the other one is also for JMA. All of the training resources you provide are really, really important. So please do communicate back to MSC and Besho-san and others how much they are appreciated, because they're really cool.
Okay, thank you very much.
Okay, just a second. I'm going to check the comments online. Let's see. So we have a comment from Bodo. Bodo, would you like to unmute?
Okay, thank you. Yeah, just want to bring to the attention of attendees that in fact the study of monitoring the pumice from that Fukutoku Okanoba case study, Handa-san presented that during a VLab session as well. So if attendees are interested to know a little bit more about that, the pan sharpening, and so I've actually provided the link. Thank you.
Thank you too.
And Bodo, did you have a second comment as well a little earlier about the Himawari request service?
Oh, yes, certainly. I will say one thing, that the Himawari request service, JMA have made that available to countries throughout the Asia Pacific region on request a few years ago through that Himawari request service. And it's a very, very useful service indeed, having for high impact weather such as fires, tropical cyclones. You now are able to use 2.5-minute imagery instead of 10-minute imagery. It's very, very useful. And what we've tried to do as a little thank you is to develop case studies, local case studies, and to disseminate how useful that new Himawari request service is for bushfire, for fires, as well as tropical cyclones and typhoons back to the community. So I just wanted to mention, highlight that. Thank you.
Thank you very much.
Just a quick comment. It's in line maybe with your question. Since I'm part of this 3T forum that we're running globally, and we're trying to understand who does what and what are the advancements in the application areas, I try to pay attention what is happening also in the Asia, and we had the interactions with JMA and with Bodo as well. I have a feeling, and correct me if that's wrong, that JMA is very much collaborating and having their ears open to what's happening around. Along this is Bodo's comment prior, that they're actually sharing this special service, scanning service requests in the region. So I think they really have a good feedback from the users on the products. That's my take.
Yeah, I think so.
Yeah,
thank you for being open. Yeah.
And if I can just add a comment as well to the session, is that a lot of these, pretty much, well, the case studies I was talking about are actually have been recorded, and they are available for the broader global community as well. So, and I can certainly forward the links afterwards.
Thank you, Bodo. Any other questions or comments? Yeah, go ahead, Javier.
I have a question. If JMA is working, I think it's KMA with the Koreans, because they have Geo-Composite in a similar position to Himawari. When would you use Himawari versus Geo-Composite? Are they like complements or replacing a function? Do they have different bands? Does JMA work with the Koreans on the geostationary framework?
Yeah. So the question is, does JMA collaborate with Korea, with Korea's geostationary GeoComsat, or does JMA primarily use Himawari?
Okay. We'll talk about. Yeah.
That's fine. Great.
Okay.
Thank you. Anything else? Oh, yes.
Can I make a very, very quick comment regarding the the Himawari-9 and GeoComsat? We have actually done some experimental work and received great feedback from both JMA and KMA staff about this, using the Himawari-9 and GeoComsat in stereo 3D type rendering, so that you can actually then potentially also evaluate well, not only the 3D aspect of atmospheric and cloud features, but also potentially cloud drift wind, superior cloud drift wind height determination. So that is work in progress.
That's great. Thank you for that, Bodo. There's been some work in NOAA as well with stereo cloud height assignments for winds using goes east and goes west, where they overlap.
And yes, I've got quite good correspondence with Scott Lindstrom on that topic. I think he's really interested in that too.
Great.
Okay. Actually, I brought some souvenirs from Japan, so please enjoy them later.
Great. Thank you for that. And we'll lay those out near the lunch so people can take them. And so thank you very much for that.